I just put some additional notation there. You can see that this thing is also known. I just define this as a E5, which is the I considered as a local error happen in local error happen in node 5. Okay, local error in node 5. So if you talk about E5 is a local error happen at node 5. If you talk about small e6, it's a local error happen at the node 6. So I just define another notation there. I put another notation there. So don't get confused why I add more and more notation there. There's a purpose there. Later, in order for us to generalize the algorithm, we need to have if we define this, it will be beneficial if we define this notation, because later you will see the purpose is we want to generalize all the things. Okay, just added that. Assume that E5 is the error happen at the error. E5 is a local error happen in node 5. Okay, which is expressed as W1 actual Y1 minus the predicted Y1. Okay, and negative value there. And I also introduce you with another notation which is also known as a local gradient or node delta, or this is also known as a delta. When I said delta 5 is a or node delta 5 is actually a local gradient of node or neuron 5. Okay, so again, it's the same expression there. Okay, same expression as this one. I just bring it at the center there, and then I define that this component is your delta 5. What is delta 5? Delta 5 is a del E over del net 5. So meaning that if you talk about something related to neuron 6, it will become delta 6. Okay, this one I want to generalize the some things there. That's why I introduced you with two notation there. One is E there, another one is delta. Okay, delta. So if in this case, delta 5 is defined as del E over del net 5. So if I try to generalize there, if you talk about neuron 6, the delta 6 is represent a delta inside the neuron 6, which is defined as a del E over del net 6. Okay, you just need to remember this is just additional notation in order for us to generalize this or to make this mechanism generalized later. So that's why I need to use this term. Just remember that if del E over del net is defined as delta, then del E over del net 5 is delta 5. Okay, that is just assume that, because this is in some textbook they call it as a local gradient, means that the gradient happen inside the network. Okay, if this is a delta 5, okay, this is the gradient happen inside the network before you, of course, the error that happened there, this is E5, sorry, this is E5, and then E5 will produce the delta 5 there, and then it will going towards propagate the error towards the back during the backward pass. It will propagate the error to direction from output layer to the input layer. That is it. Okay, so again, so del 5 delta 5 again is equal to del E over del net 5. So this is the component. So if I want to express again what is del 5 in this way, then is equal to, okay, you can see that now because I already defined this one as our E5, or the local error happen in not 5 as E5, and then now the delta 5 is actually a gradient, local gradient happen in not 5, which defined as a del E over del net 5. So to find your your delta 5 is equal to your f derivative of your activation function multiply with E5 over here. So again, if I can simplify the expressions there in order for you to find sorry, this one should be again there's a alpha there, I forget to put there, this is alpha there, and then it should be alpha time delta 5 time O3. So in other words, to find the updater of W35, then you can just simply multiply between your learning rates with your delta 5, where delta 5 is defined as del E over del net 5, time the O3, which is this one. So in order for you to find the del 5, you can compute this one. Okay, so don't you might asking why just not direct compute my del E over del W35 directly by express this one. Of course, if you want to do it from scratch, then you can also do it from scratch like this one, and then once you find this one, then you can compute from this expression, you can compute the value. You can start execute this one to get value that can represent your del E over del W35. But I just added a few notation, which is E5 and delta 5, and then I define that my delta 5 is equal to del E over del net, and actually this one is come from here, and then after do some replacement and manipulation, I find out actually my updater W35, my updater of W35 there is equal to this one, which is the same things, and then I'm using this notation delta 5, is not using this one anymore. But of course, I just want to show you that this one is the similar thing as what we express over here. Okay, it's nothing, but why I make you suffer by introducing another variables or another notation here, which is delta 5 and E5, because later we will use that to generalize all the equation. That is the purpose. Okay, just remember that is the purpose of generalize all the things there. Later you will see that, we will see that later. Okay, so of course, if you talk about all parameter involved in output layer, in order for you to find the updater of every parameters there, doesn't matter is it W or B, then you can repeat the same process like this one, and then that is what you get in general. Or in general, we can express in that way. Means that to find the updater of W35, you need to multiply between your alpha, delta 5 and O3. To find the W45 updater, then you need to multiply between the alpha time delta 5 O4. And then for the bias B5, the updater, you need to multiply between the alpha times the delta. Actually it should be time 1, but I just remove it. Okay, time 1, remember this one, just imagine that. Okay, now you can see the patterns there. Okay, you can see that of course every updater you need to multiply with alpha. That is of course alpha need to multiply with your gradient here to find the updater. But of course this one It's just simply if you set into alpha with certain value, then you just multiply with the gradient. Now for each and every gradient here, for example, gradient happen here, gradient here, so del E over del B5, how to find that? Because again, this one can't is the one that you need to multiply with alpha, so you can get the updater of B5. So how to find that here at this one? So then you just simply multiply between the delta 5, okay, multiply with 1 to find, okay, so that's how you get this one should be multiplied with 1. So to find the del E over del W35, you need to take this del 5 multiply with O3. So that's why here you can see that to find W35, delta 5 multiply with O3. Okay, delta 5 multiply with this one, you get this one. Delta 5 multiply with this one, you get this one. And then again to find del E over del W45, delta 5 multiply with O4, then you get this one. So you can see that that is the pattern. So that's why I introduced to you with this delta 5, which is a local gradient. Okay, it's a local gradient inside this node. Local gradient of node 5. Okay, it's beneficial for you to generalize everything. It means that at the node 5 to find delta E over delta B5, then you just multiply your this one with this one. To find this one, multiply this one with this one. To know this one, multiply this one with this one. So then you get everything's there.